Hello, and welcome to this network optimization case study. Our client is a US-based company evaluating a critical decision to streamline its logistics network. Currently, their supply chain includes 2 manufacturing factories located in Cleveland and Belleville, 4 distribution centers DCs in Wellston, Norwich, Centreville, and Syracuse, 98 customers served nationwide. With market growth slowing, the management is considering consolidating production by closing the Cleveland factory. Their goal is to assess the financial and operational impacts of this change. Specifically, their goals are threefold. First, to analyze the total and detailed costs of the current network, including site operations, freight to customer, and freight to DC logistics expenses. Second, to evaluate the cost impact of operating solely with the Belleville factory, assuming its production capacity can be scaled up. And finally, to explore how the current network would change if only the Belleville factory remains operational. To effectively address these questions, we will collect data and build a digital supply chain model using Sophus X. Through this project, we're confident you'll rapidly grow into a supply chain modeling expert. Before diving into the modeling process, let's take a moment to understand the foundational inputs we'll use in Sophus X to build our supply chain model. These inputs are grouped into 2 categories: physical elements and business elements. Starting with physical elements, these define the tangible components of the supply chain. The periods table sets the model's start and end dates. The sites table defines network nodes like factories, warehouses, and customer locations. The products table lists all items flowing through the network, from raw materials to finished goods. Moving to business elements, these tables capture the rules and policies driving operations. Customer orders include details like order quantities and delivery destinations. Production policies govern where manufacturing is allowed and what products can be made. Inventory policies set storage capacities and costs. Sourcing policies define approved suppliers and lead times. Finally, transportation policies outline shipping routes, transport modes, and associated costs.
Begin by navigating to the Sophus X website and logging into your account. Once logged in, create a new folder. Name it Tutorial followed by your own name. For example, Tutorial John if your name is John. Open this folder, then click Create New Model and give it the same name as your folder. With the model created, it's time to import the data we discussed earlier. Open the Tutorial Inputs Excel file. You'll see for sheets, periods, products, sites, and customer orders. Now return to Sophus X, click on Import and Export in the left side menu. Then select Import Data from the submenu. Browse to the file, click Open, and choose Replace to ensure all data updates correctly. Now that our data is imported, let's explore how it's structured in Sophus X and check out the key details of each table. Take periods as an example. Model horizon starts at January 1, 2020 and ends at January 1, 2021. Next, navigate to the products table. This includes 10 product entries, each with fields like value, price, volume, and weight. The products defined here will be directly referenced in customer orders and other business elements like production policies and sourcing policies, ensuring consistency across the entire model. Now, open the sites table. Sites are categorized as existing facility, for example factories, DCs, or customer. Key columns like site type, fixed operating cost, and geographic coordinates latitude, longitude define each site's attributes including its location, operating costs, and capacity. This ensures the model accurately reflects real-world logistics capabilities and constraints. Finally, explore the customer orders table. It organizes details such as order quantities, delivery dates, and destination sites, reflecting how demand data is structured for analysis. Now go back to the sites table. Create a filter for factories, DCs, and customers. Type in CZ in filtering row for site name. Should find 98 rows filtered. Type in CZs and click on OK. Repeat the same procedures and create MFGs and DCs. Go to Model Output Map and create a new item named Map. Click on Add Point Layer. Name the layer CZs. Data source is set to sites. Filter is set to CZs. Customize shape, size, and color in your favor. By dragging a layer, change layer display. CZs is on top. DCs is on bottom. Group is useful when defining business policies, which we will touch on later. Now, let's go to sites and create 3 groups for customers, factories, and DCs. Let's begin with customers. Select CZs from filter list and click on Add to Group. Choose New Group, All Customers Individual, and add filter result to group. Complete with factories and DCs. With that, all models, elements, and groups have been defined in our model. Next, let's define business policies. We'll begin with production policies. In this case, all factories are allowed to produce all products. Next, we will go to Sourcing Policies table and define product sources for customers and DCs. 2 policies are created. One is that all DCs can source all products from all factories. The other is that all customers can source all products from all DCs. Transportation policies can be used to define logistics-related parameters, such as variable cost and cost basis. In our exercise, cost basis of all lanes is weight distance. And for freight to customers, variable cost is 0.00075. For freight to DCs, variable cost is 0.0003. Last, we go to Inventory Policies table where we will define where to store what products. In this simple exercise, we allow all DCs to store all products. This is the last step of creating policies for a basic model. To study the impact of closing Plant Ohio, we will create a scenario, and begin with Scenario Item. Go to Scenario Item and create Exclude Plant Ohio. Associate with Sites table. Filter out Plant Ohio and then set its status to Exclude. Go to Scenario and create a new item, Keep Only Plant Illinois. Move Exclude Plant Ohio to the right and we are done. Go to Run Queue and click on New Run. Select all to Scenarios and click on Add. On Run Queue, we can see the status of different runs. Success indicates a run is complete with no error. Running indicates a run is processing. Waiting to run indicates a run will start when the previous run is finished. After finishing a run, we can go to Network Summary and begin with the analysis task. On total level, closing down Plant Ohio lowers profit to 0.68 billions. Compared to baseline, the savings in operating cost is not enough to cover the increase of transportation cost. And why is the savings in operating cost is lower than expected? We try to understand why the model gives less savings in operation cost. Go to Site Summary. It is noted that Plant Illinois has to increase its operating level and thus incur a higher operating cost than baseline. Next, we go back to Map and add Connection Layer. We create 2 connection layers, FTC and FTB. We first go to an Output Table Flow Details and set up filters. Then we select Connection Layer and edit the display with provided options. On Map, we can switch scenario to Keep Only Plant Illinois. Study the decision impact on FTB and FTC flows. Note that both FTB and FTC flows make a change given that Plant Ohio is closed. To further study, we can go to Flow Details Output Table. Flow Details shows detailed model outputs. Take DC Ohio as an example. We can see scenario differences of source, flow, quantity, and cost. With all that, we've completed this applied practice of network optimization.
In this video, we have walked through the following points. Create a model of network optimization. Batch import model data. View data of inputs and outputs tables. Create filters and groups. Add business policies. Create a scenario with a decision-based scenarios item. Add scenarios to task queue and run. Study run results from different perspectives summary, map, and details. I hope today's sharing can give you a deeper understanding of network optimization modeling on Sophus platform. Thank you.